Thank you very much for giving me this opportunity to share one of the subjects I've been working and to talk about the Congo Basin regarding the flood for the first time with this big audience, which is the GFP. I will be talking about the application of open access data for flood risk assessment in the Congo Basin. And this project is part of the Congo River User Hydraulic and Morphology Project funded by the UK. The project was the consortium of the University of Kinshasa, the University of Tanzania, the University of Rhodes, and the University of Bristol. So far, what will be done regarding the flood in the Congo Basin? It was about the characterization of the flood. And the idea was not only to determine the risk map with the flood period. Beside the flood period, as I can say, the flood seasonality, we should also come up with to know about the historical and the future flood change, mostly the trend of flood according to history and the future trend. And as you can see from this figure, the urban station, the historical trend for the flood, it shows that the trend from the historical trend, the flood was downward. The third point was about to determine a suitable procedure for determine flood frequency analysis within the Congo Basin. That was the first time in the Congo Basin to come with this exercise, this data. And we successfully did have some results that will be published soon. And as you can see from the Kinshasa station, we found that the Gumbel distribution was suitable to determine the flood frequency analysis within the Congo Basin, mostly in the Kinshasa station. Coming about risk assessment within the Congo Basin, it's what will be talking now. Why we try to work on the Congo Basin regarding flood risk? It has been reported since that the Congo Basin is a flood-prone area. As you know from the literature, that the Congo Basin is almost a low-lying area. It means that the risk of flood is very common in the Congo Basin, and that represents almost 40% of natural disaster within the Congo Basin. And that has been reported for many time, and that was really a big issue and still be the big issue within the Congo Basin. And the idea was to try to work on the flood risk, but the challenge was about how could we found the flood risk in Congo Basin. Why? Because most of the fine data that is found in the market was costly, and we need to find the open access data that can help to use to solve the problem of flood risk in the Congo Basin. It's why we used the list flood, derived flood map, which is open source we get, and thanks flood map for different, excuse me, for different time period. I think it was from 5, 10, 20, 75, and 100-year return period. Beside the flood map, we got also some observed flood map extent that help us to validate our flood map hazard. And that was the MODIS images, about 250-meter resolution. We used also the population, the world population pixel, which is available online. It was about 30-meter resolution, and we come up with some infrastructure layer. And from the infrastructure layer, we have like road or building and so forth. That was open data source that we got to use under our study. And the open access was really helpful. And before to come up to one is was about the validation of derived flood map, the list flood derived data. For the validation, we used the MODIS and the DFAO flood images. And the second procedure was the extraction of population and infrastructure exposed to floods of 500, 20, 50, and 55, and as well as 100-year return periods at almost 500 territory within the Congo Basin. The third point was the determination of the hotspots territory. And the last point was establishing the flood risk map for the Congo Basin. The aim of those exercises was about to assess the capability of open access data, which can assist the police decision for flood risk management and can enhance communities' resilience in the Congo, particularly, and why not for the African region, where the data is really very scarce. All those processes were under our flood risk analysis framework, as you can see from the figure. And the framework was twofold. The first one is it was about flood hazard analysis, and the flood hazard analysis was based on list flood. And the list flood, the first component, they have two components. The first component was about characteristic of the catchment. And the second one, we use the characteristic of the rivers, combined with vulnerability elements, which has road or residential building, and we overlay them to come up with a map regarding the flood risk within the Congo Basin. Our approach, we found that combining those two open source data was successfully regarding the Congo Basin as a region, because there were agreements in terms of the location of flooded area between the observed and the model. The observed was about MODIS, and the DFAO observed the data. And what was reported by the DFAO was that there were 34 territory within the Congo Basin, which was reported as having experienced large flooding. And that was also found within the model. That was really a good result, because what we was trying to find is just to assess that open data source can be used for flood risk analysis at a regional scale. And the second point about the open data source was to try to validate our observation, mostly about, because the list flood data we are using, we did not use the flood depth, we use only the flood extent. And we try to validate that using the SACE score. But from the score, we can see that there were agreement for some area, but other area, there were not agreement. But the disagreement for us was attributed to some area which was not connected, which was not found, let's say, was not captured by the satellite, but that was done within the model system. In addition, we found that another factor that could not help to have agreement between the observed and the modeled flood was the forested area, because as we know that the Congo Basin is the forested area. That was, and most of the difficulty that the satellite image have to face is about the forest. That was one of the elements that can affect the agreement of observed and the model. But we think that the model, the global model as a risk flood product, was really suitable to capture area where it was flooded. Especially what we found that is about the location of flooded area. And most of the time what we find is that all area located along the main channel was really most affected, as exemplified by the flood of 2000. That was really a big flood. And that flood was the 50-year flood return period from our analysis. And we are assuming that the paper will be soon published. And that was the 50-year flood return period, and it was really a big flood. And almost all the Congo Basin was affected. But the Congo town, Brazzaville, Kisangani, and Bukavu was the most affected because of the population density and the location along the main river. And about the affected population within all the Congo Basin, we found almost 1% of the population was affected within the basin. As regard to the exposure for each territory, we try to come up with the most exposed territory. We found 20 of them, and we try to fix the relative and absolute exposure. And from the graph, we can see here that relate to absolute exposure, Kinshasa, Bukavu, and Isangi was really having high exposure, but about absolute exposure, Kinshasa and Bukavu was really having high exposure, but relative exposure was found from Bomongo and Buterere. And those factors, we try to come up with this factor because mostly if we are dealing with flood risk analysis is about assisting people and assisting those NGO for flood management. And those two factors, absolute and relative exposure, are the most important factors that can be used during the intervention nature. Relative to the hotspot area, using the open access data, mostly the remote sensing and this flood hazard map, we found almost as reported by DFU. DFU reported that there were almost 34 flood-prone area within the Congo Basin. And for analysis using the this flood hazard map, we found that the Congo Basin has almost 38 flood-prone area. The factor that was linked to most of the factor beside the rainfall and so on, we think that the population density and location in low-lying area are important contributor to the degree of risk in the territory, such Kinshasa, as we know that Kinshasa is one of the big cities within Africa, and people are trying now to settle within the floodplain area. That was one of the reasons Kinshasa is the most exposed territory, the most exposed area within the Congo Basin. It's the case for Bangui, Bongandanga, and Bongandanga mostly we try to find the reason why it's exposed, even if they have no more population, but the exposure for the Bongandanga and other population, because those areas, they are found within the Kivet Central. And the Kivet Central, we know that this is the very low-lying area. It's almost zero in terms of altitude. That's we found that this is area where it might be very exposed, high exposure of population to flood risk. Besides those, we have also, that was even reported in the news, pool at the Congo Brazzaville, pool and Kivet, Bomongo in the south, Kisangani and Walikale in the northwest of the Congo. That's almost the summary of our result about the flood risk within the Congo Basin. The idea was to come up with this map that could help the NGO and the government for flood management issue within the Congo Basin. And this study mostly is the first in kind, because up to now, people didn't try to come up with some study regarding the flooding in the Congo Basin. That's due to lack of data, and most of the time we need to rely on data with cost. What can say about the capability of open access data is that the global data flood model have proved to be useful for flood at a regional scale. And the combination of the flood hazard map with the remote sensing derived data demonstrate the capacity for predicting flood risk in the data scarce region of Africa. We can easily that recommend this possibility, as some of the presenters say. This is some issue we can have mostly in African countries, but the open source data can help at least to show where flood is really, and flood is a component, is a risk from the population. At the regional scale, we say that the global data is limited, but is not limited, sorry, but at the small scale, mostly for insurance purpose, this global data will be really challenging. We can also say that the approach created a comprehensive platform for the comparing and evaluating the offer, really a good ground where we can use those different data to see how it performs well. We know that the Congo Basin is a forested area, and we know that the science is evaluating that maybe soon we'll have a solution about the forested area regarding the capability of remote sensing data. The difficulty we are having in the Congo Basin is about real-time forecasting of flood, and the planned activity was try to incorporate satellite observation technique for real-time flood forecasting within the Congo Basin. As I said, I thank you very much for your attention, and the paper for this work can be found at the address below. Thank you very much, and we are open for the question.
Thank you very much, Gode. Are there questions in the audience? I will combine with the microphone. So the people are still thinking. I have a question for you.
Yes.
Were there any data sets that you would like to have but didn't have either access to, or are just not available for your area? Was there something you were searching for that would have helped you in your study? Can you maybe elaborate a little bit more on that?
Please, I didn't catch the keyword for the question. What about the data set?
Were there any data sets that you could have used but did not have access to? And if so, can you point those out or talk a little bit more about that?
Yeah, I think about the population data, that was really a critical issue, because when I was trying to publish the paper, I've been asked to look for, I've done that there was a lot of data for the population, but that I was using, it seems like that was all the data, but we still have to perform that other. And the second one is about the infrastructure data. For the Congo Basin, most African country, the infrastructure data are not really, okay, let's say they're good quality. And what we did is just to show that the open source data can done something, but the quality of infrastructure data are not good, and we need to have more good quality of infrastructure data to come with the flood risk within the Congo Basin.
Thank you very much. Let's
Yes.